This example is like problems 4 and 5 in the exam 3 review. So in a simple random sample of 200 vials of a vaccine, the mean volume was 1.21 milliliters. So we've got a sample of 200, that is our sample size N. And then the mean of the sample was 1.21, that is X bar. We're assuming that the volumes here are normally distributed, so we can use normal CDF, z-values, with a population standard deviation of sigma 0.24. And we're rounding our critical value to no less than 3 decimal places. So first, construct a 75% confidence interval for the mean vial volume. So I've got the confidence interval formula here. And our confidence level is 75%, so that means alpha is 1 minus 0.75, 0.25. So alpha over 2 is half of 25, 0.125. So then our z alpha over 2, we're going to use inverse norm to get that. So second variables, 3 is inverse norm, and we want to put our left area in here. So if 0.125 is to the right, then our left area is going to be 1 minus 0.125, which is 0.875. So we're going to do inverse norm of 0.875. So 0.875, everything else stays the same. 1.1503, so 1.150. And so now we can go ahead and find our lower and upper limits. So the lower limit, X bar minus Z 0.125 sigma over root N is going to be 1.21 minus that Z value, 1.150. Times our sigma, which is 0.24, and divide by square root of the sample size, which was 200. And then for the upper limit, same thing but with a plus sign. So 1.21 plus 1.150, 0.24 over root 200. So let's go ahead and use the calculator. First, find our margin of error. So this will be 1.15 times 0.24 divide by square root 200. So 0.0195. So if we're using 3 decimal places, it'd be 020. So this will be 1.21 minus 0.020. And this will be the 1.21 plus 0.020. So 0.21, 21 minus 2 is 19, so this will be 1.190. And then this will be 1.230. So our 75% confidence interval, 1.190 to 1.230. And we can check that with z-interval on the calculator. So we go to stat, tests, z-interval is number 7. And we make sure that stats is highlighted, not data. Our sigma, 0.24. X bar 1.21, N 200, confidence level 0.75. So 1.19 to 1.23, and that's what we got here. Find the sample size needed. So that's going to be sample size formula, which is right here, N equals. so that a 90% confidence interval will have a margin of error of 5%. So margin of error of 5%, that's your M here, so that is 0.05. 5% is a decimal. 90% means your alpha is 0.10, so alpha over 2 is 0.05. So 5% is the area to the right, so the left area will be 0.95. So we want to do inverse norm of 0.95. So second variables, and then inverse norm number 3, and we want 0.95. 0 and 1 for mean and standard deviation. So 1.645. So now we can plug into the sample size formula. So we got that z alpha over 2, 1.645. And then times our sigma here, which is the 0.24. And then we are dividing by m, our margin of error, 0.05. And then we square everything. So let's go ahead and key that in the calculator. So let's do parentheses here. And we've got 1.645 times 0.24 divided by 0.05. Close up our parentheses and square it. So 62.3 approximately. And with sample sizes, we always round up. So not standard rounding, but always round sample sizes up, because 62 is not enough to quite get that margin of error of 0.05. And then let's see here, manager here claims that the mean vial dose is actually less than 1 milliliter. Does the confidence interval contradict this claim? Okay, so our confidence interval here was 1.19 to 1.23. So our 99% confidence interval is 1.19 to 1.23. And if you graph that on the number line, so you got 1.19 here and 1.23. And so the manager is claiming that the volume is less than 1 milliliter. So that 1 is down here below the 1.19. Well, this is a 75, I'm sorry, this is a, which confidence do we have here? Yeah, 75%. That's a 75% confidence interval. So what that means is that 75% of samples will give confidence intervals containing the population mean, mu. And he's claiming that the mean is 1. That's not in our interval, which happens 75% of the time. So does the confidence interval contradict this claim? Yes, it does. So since the claimed mean is not in the interval, that's when you get the contradiction.